Okay, so we will be working with the geometry proofs today. So I'm going to start talking about algebraic proofs and what that would look like. So first, the definition. A proof is a logical argument where each statement is supported by a reason. So it is a logical argument where each statement is supported by a reason. There are three different types of proofs. The first one is a two-column proof, flowchart proof, or a paragraph proof. We will mostly be doing two-column proofs. We will talk briefly about flowchart proofs, but we will not be doing any paragraph proofs. So just to remember, because I know we've talked about this, but a postulate is a statement accepted as true with no proof. Okay, so just a statement accepted as true. So you can basically see that it's true, or we know logically that it is true. Where a theorem is a statement that has been proven true. Okay, so a statement that has been proven true. We know it is true because there is a proof behind it that says, yes, this does work. Okay, so then going down here, so properties of real numbers. These are the property names, and you will get used to these and start using them so commonly. I would say almost all of these are used so commonly during proofs. We basically need to know exactly what they are and what they say. A lot of this stuff you've been doing a lot already, and you just don't recognize it by the name. So for example, the addition property of equality. I reference that as POE a lot. That just means it stays equal. So it's not changing the equation at all. So for example, if A equals B, then A plus C equals B plus C. The example is if you have x minus 5 equals to 22. To solve for 5, you have to add 5 to both sides. That cancels out. X is 27. So again, you're so used to doing the addition POE that you don't even recognize you're doing it. But now during proofs, you have to back up every statement, so you will be using that property quite a bit. Same thing with the subtraction property of equality. If A equals B, then A minus C equals B minus C. Again, you would just go ahead and subtract 3 from both sides, and X equals 44. Multiplication property of equality. If you multiply both sides by the same number, you're not changing it. So here, x divided by 4 equals 10. If I go ahead and multiply both sides by 4, those equal 1. So then x equals 40. Division property of equality. If you divide both sides by 5, then x equals 9. The reflexive property of equality, you're not used to using this one, but we will have to use it quite a bit when going through proofs. And I think of the reflexive property as if you were looking in the mirror at your reflection. If you were looking in the mirror, you see yourself. So you see the same exact thing on the other side. That's the same thing here. So A is looking in the mirror at itself. So A equals A. So then here, measure of angle A would then equal itself, or measure of angle A. The symmetric property of equality, you can flip the order. So x equal 8 implies that 8 equals x. transitive property of equality. If A equals B and B equals C, then A equals C. So we're looking for some sort of overlap. So for this one, if I write this out that A equals B, B equals C, there's this overlap here, so I can take the middleman out and just say that A equals C. And it's the same thing. So measure of angle B equals measure of angle C. If measure of angle C equals 82, then we can go ahead and conclude that measure of angle B will also equal 82. Substitution property of equality again. If A equals B, then A may be replaced by B in any equation. So if x plus y equals 20 and x equals 8, then we can plug 8 in for x and say that 8 plus y equals 20. That's substitution. Distributive property, you can multiply those. So this would become, if you multiply that in, 15x plus 20 here. Commutative property, you can flip the order, and this is allowed for multiplication and addition, not division and subtraction, so keep that in mind. So if AB equals BC plus 2, then AB equals 2 plus BC. I can flip that order. All right, on the back, we're going to start off with some proofs. This is your first time seeing a proof, and these are algebraic, and I love them, but you will use a lot of the terms on the front side, so you will get very used to seeing these. So the first statement, most of the time, I would say about 95% of the time in a proof, you have to start out with what is given to you. So you have to be given some sort of information. So what they put over here on the side is very important, because what you are given and where you are headed, you need to keep that in mind throughout the whole entire proof. So your first statement is going to be 3x minus 9 equals 12. And the reason for that, well, that was just given to me. So like I said, about 90% of the time, not always, but most of the time, you will start out with what is given to you. So that first line, you have to be given some sort of information. So that's what you're going to put. Then you're just going to follow the same exact statement of how to go and how to solve this equation. So over here on the side, if I were to solve this equation, 3x minus 9 equals 12. We need to get x by itself, so I'm going to add 9 over 3x equals 21, and then divide by 3, and x equals 7, which is great because that is what I am trying to solve. Okay, but my first statement, the first step that I did in order to solve this was add 9 over. Okay, but you're not going to show that over here. You're just going to show the next step. And my next step was this 3x equals 21. So I'm going to put 3x equals 21. How did I do that? Well, I added 9, so that is the addition property of equality. And then now, my last step, x equals 7. How did I get there? Well, looking over here at my work, I took 3x equals 21 and I divided by 3. So this is going to be the division, POE. So you're just taking an equation, solving it, but you're really not showing any work. So if you need to work it out over to the side, then I would do that first. Okay, example 2, we're given that 2 times 3 halves x plus 8 minus 4 equals 30. So I'm going to start out with what's given. So I'm given that 2 times 3 halves x plus 8 minus 4 equals 30. And again, if you need to go off to the side and solve this out, then do that. I'm going to do it for this one, but really not for the rest of them. So here's my equation. And then you can decide where to go from here. You can either add that over or multiply first. We're just going to go ahead and distribute this through. So 2 times 3 halves is 3. And then 2 times 8 is 16. So that's my final line now. So I'm going to put this over here. So 3x plus 16 minus 4 equals 30. And then what did I do to do that? To get that line, I multiplied the 2 in, which is called the distributive property. Okay, then coming back over here, what do I need to do next? Well, I see this 16 and I see this 4, so let's go ahead and add that together. So 3x plus 12 equals 30. Well, that's my next line. So 3x plus 12 equals 30. And how did I get that? Well, I just simplified the 16 minus 4, so my reason here is simplify. And if I come back over here, I need to then subtract 12. So I get 3x equals 18. This is going to be my next line. Again, over in the proof, you don't show really any work. So I'm going to put 3x equals 18. How did I get there? Well, I took the last step and I subtracted. So that's the subtraction. Property of equality. And then my last step, what I have to do, divide by 3 to get x equals 6. So then here, x equals 6, and I divided, so division, POE. And then I'm good because my last step should always be exactly what this proof says. Okay, so I need to end with x equals 6, and I did. Okay, our last one, this one gets kind of tricky because there's a lot of variables going on, but that's okay. So my first, second, and third line, if I look here, that is all what I am given. Perfect. So I'm just going to write given on all of those. You can either put all of your information that's given in one line, or you can split it up into multiple lines. I like to split it up just because to me that makes a little bit more sense. But again, if you want to put it all in one, it just depends. Okay, and then I have to look, I'm looking to see where I'm getting, so I'm looking for it to be all in one equation. So then here, if I see that P equals 3R and M plus N equals P, so I'm going to go ahead and set M plus N equals 3R, and here is my common point. So then that's the transitive property. But they also told me that M equals N, so I'm looking for M not to be in my final equation anymore. So then here I'm just going to say N plus N then will equal 3R, and that is substitution because I am replacing M with N. Then I can go ahead, I see N plus N, that's two variables that are alike. That would be 2N equals 3R. That would be simplifying. We're close, but do you see how my proof statement has 3R coming first and then 2N at the end? So we need to flip that around because, like I said, your last statement needs to look exactly like what you were trying to prove. So this should be 3R equals 2N, and that would be the symmetric. That is the symmetric P-O-E, because we're flipping it around. Other reasons we will use so far is simplify, which we used throughout this sheet, segment addition postulate, which we learned in Unit 1, and the angle addition postulate, which we used in Angle 1 as well. And that's what this is saying. So two segments or two angles add to equal the larger segment or angle.